Okay, good. I think everything okay now. Okay. 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 Uh, Good evening. Today we are going to discuss about our very new lesson, fluid mechanisms. Fluid mechanism. That's as I told, this is the most important lesson in the final physics lesson to complete. This is a final physics lesson. Uh, Sorry, net connection. Okay, after this lesson, we only have one. Sorry, we have another physics lesson. Electricity also we have. Uh, Actually, in our syllabus is a final one, but our missed lesson is the electricity we need to complete. After the final day, we can discuss electricity. Electricity is not too difficult, it's easy. Electricity, the basic of electronics we discuss, not advanced, the basic only we discuss, but in fluid mechanism we discussing everything in advancement. Okay. Fluid mechanism. Fluid mechanism. Okay, when we discussing in this lesson, we mainly discuss about fluids. Do you have any idea what is the meaning of this fluid? What are the fluids? Do you have any idea? Do you have any idea what is this fluids? Fluids in Sinhala Tarala කියලා කියන්නේ. Fluids. What is the meaning of these fluids? What are the fluids? Fluids. Do you have any idea what we can separate fluids and non-fluids? What is the main point we can separate fluids and non-fluids? Any idea? Any idea? Yes. Yes. Fluid can flow while non-fluids don't. Sorry, non-fluids don't and maintain their space. Yes, the main thing is that we called as viscosity. The viscosity means flowing ability of any fluid. Flowing ability. If any matter, normally you already know, uh, the there are three main physical states. They are solids, solids, liquids, and gases. Physical status, physical status of matters. There are three types: solids, liquid, and gases. Solids, liquid, and gas. When we consider about this physical status of matters, solid physical state, you already know their molecules are attached like this. They have very strong intermolecule bonds. Very strong intermolecule bonds, and their intermolecule spaces are very low. Intermolecule spaces are very low. Their intermolecule bonds are very strong. I told when we apply any pressure or whatever, very difficult to separate some molecule. Very difficult to separate. It is tightly attached because it's the bond between molecules are very strong bonds. But when we consider about liquids, you already know liquids, the molecules are formed like this, same, no more spaces, but their intermolecule bonds are not strong like solids. It is less strong than solids. The strong is lower strong than solid. Okay, that this point in physics you need to understand this every theory in every definitions in practical way. In solids, their intermolecule bonds are very strong. Intermolecule bonds are very strong, therefore they can't anywhere travel. Molecules can't anywhere travel because of their intermolecule bond between molecules. They have very strong bonds, intermolecule bonds are very strong, very strong, very strong. Okay, when we consider about liquids are not uh, their molecules are close like solids, but their intermolecule bonds are not strong like solids. It's in medium, we can say the medium level strong bonds, medium strong. That's very high strong bonds. It is strong bonds, strong bond, medium strong bonds between molecules. Okay, in liquids. Okay, when we consider about gases, you can see gases, their molecules are very freely available. You can, I think we discussed already, molecules are free in gases molecules are freely available. That means gases molecules are free mean their intermolecule bonds are very low, very weak intermolecule bonds, weak bonds, that we called as weak bonds between molecules, weak bonds between molecules, weak bonds between molecules. Okay, now we discuss there are three main physical status of matters. We already know solids, liquid, and gases. We already know the molecular structures also we already know in the previous lessons. Now I told you the solids, you already know in the previous in thermal chemistry, kinetic chemistry lessons. The solids, the intermolecules, they have very strong bonds. In liquids, they have medium strong bonds, and gases, they have weak bonds between molecules. Okay, now when we consider about these solids solids, this when we apply any pressure or any actually any pressure difference, solid don't have any flowing property. Flowing property that we called as viscosity. In physics, that we call the flowing ability, that we called as viscosity. The viscosity, the solid don't have any flowing property. What is the reason? Because due to this strong bonds. Solid intermolecule bonds are very strong, therefore they don't have any flowing property. They don't have any flowing property, that we called as don't have. I think in with reason, if you understand, it is very simple. It is very simple. Because of their intermolecule very strong bonds, they can't molecule can't separate, and it is a fixed shape. It is fixed. It has a solid object has a fixed shape, and their molecules are very tight. It's not loosey, not cannot separate. Okay, therefore it's don't have flowing property. Don't have flowing property. Flowing property. Flowing ability. Don't have flowing ability. Remember, solids. You already know solid object cannot flow. It has a fixed shape. It is a fixed solids. Okay, then when we consider about liquids, liquid very special. Liquid actually very special. I told in liquids also molecules are still closed. Molecules are close to each other, but bonds are not strong like solids. It is medium level strong bonds between molecules. Therefore, these liquid molecules, remember that. Think this is a one liquid molecule. This is another liquid molecule. Liquid molecules, they can more like this. They cannot separate. Liquid molecules cannot separate, but they can. අපි නිකන් කියනවා ඒකට කොහමද in සිංහල නිකන් ලිස්සල යනවා වගේ. හරි. They can move with these bonds without separate. They can move. They can move. That we, because of this reason, when we add any liquid into any container, liquid take the shape of this container. You already know. Liquid take the shape of this container due to these characteristics. What is the characteristic? When we the molecules bonds are not strong, like not very strong. They are slightly strong. But molecules are still close to each other. Therefore, they cannot separate due to this bond, but they cannot freely available. These molecules cannot freely available, but with these bonds, they can move. Even with these bonds, they can move. That we call as. That's why in every liquids, when we add into any container, that the liquid takes the shape of the container. Understood? Okay. Now it has a flowing property. The liquid has a flowing property. Solid don't have any flowing property, as I explained. Okay, now when we consider about weak bonds available gases physical state, their molecules are freely available. Molecules are freely available mean molecules are freely available. They are very weak bonds between molecules. Therefore, it is freely flowing in the environment. Not like liquids. It is freely moving, freely flowing in the environment. That's also, therefore, that also has very good flowing property. It's also a fluid. Then you can see there are three main types of physical state of matters. They are solids, liquids, and gases. Solid has very strong intermolecule bonds between molecules. Therefore, solid don't have any flowing property. We not consider as solid. We not consider as solid we not consider as fluid. Liquid medium level strong bonds, therefore they can, even with bonds they can move, therefore the liquid has a flowing property, therefore liquid is considered as a fluid. The gases has very strong, very weak bonds, very low strong bonds, weak bonds, therefore they are freely flowing in the environment. That's also we consider as fluid. That also we consider as fluid. Understood? Very simple thing I explained. Understood? Okay, good. Okay, now wait, I need to share your tudes. Okay, check the group chat. I have sent you tudes. Tude. Within within 2 to 3 days, the printed tudes of fluid mechanism, environmental chemistry, and cell structure, all 3 books you will receive within 2 to 3 days. Now don't think, actually this basic part don't have in the tude. We have to note down these basic parts at the mid, the in syllabus given things only available in the lesson in the tude, but we need to discuss from the beginning level, otherwise we can't understand later advanced things. Okay. uh, Okay, now this is the main thing. Then you know what is the definition of fluid then? Do you have any idea what is the definition of fluid? The definition of fluid is if any matter has a viscosity or flowing property, that we call as fluid. If any matter contain flowing property, flowing ability, if it is has any flowing ability, that we called as fluid. Okay, now you know, already know the uh, liquids and gases are the main fluids. Liquids and gases are the main fluids. Remember that. Liquid and gases are the main fluids. The solid is not a fluid. Solid is not a fluid because it don't have any flowing property. Okay, write down. Write down the topic is fluid mechanism. Take a separate paper because this the basic parts you need to attach to your printed tudes. Okay, then you have full notes for a fluid mechanism. Take a separate separate paper. I think it's better. It's better. Okay, write down. Fluid mechanism is the topic. The topic is fluid mechanism. Fluid mechanism. Write down first point. Any matter, any matter, any matter with flowing ability. Any matter with flowing ability. Flowing ability. Any matter with flowing ability. Within bracket, viscosity. 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 Close the bracket. Cold as a fluid. Cold as a fluid. Cold as a fluid. Cold as a fluid. Any matter with flowing ability. Any matter with flowing ability, within bracket viscosity, close bracket, consider as a fluid. Consider as a fluid. Second point, there are three main physical status of matters. There are three main physical status of matters. There are three main physical status of matters. Among that, liquids and gases, among that, liquids and gases consider as fluids. Among that, liquids and gases consider as fluids. Among that, liquids and gases consider as fluid. Okay, now you have to make note down small short note. Draw the solid physical state, liquid physical state, and gas physical state, and note down these bonds are very strong. Then I will, within one point, I will give you reason why the solid is not a fluid. Okay, note down quickly. This one don't need. This part don't need. Okay, only this part. Okay, complete. Are you completed? Okay, write down with star mark. Write down with star mark. Write down with star mark. Solid physical state. Solid physical state between molecules. Solid physical state between molecules has very strong intermolecule bonds. Between molecules has very strong intermolecule bonds. So solid physical state between molecules has very strong intermolecule bonds. Therefore, solid physical state don't have any flowing ability. Therefore, solid physical state don't have any flowing ability. Therefore, solid physical state don't have any flowing ability. Then solids not considered as a liquid. Solids not considered as a liquid, not considered as a fluid. Solids not considered as a fluid. Solid not considered as a fluid. Then solids not considered as a fluid. Second star mark. Second star mark. Liquid physical state. Liquid physical state. Liquid physical state between molecules has slightly strong bonds between molecules. Liquid physical state between molecule has slightly strong intermolecule bonds. Slightly strong intermolecule bonds. Liquid physical state between molecule has slightly strong intermolecule bonds. Slightly intermolecule bonds. Slightly strong intermolecule bonds. But even with these bonds, even with these bonds, liquid molecules, even with these bonds, liquid molecules can move without separate each other. Can move without separate each other. Without separate each other. Without separate each other. Therefore, always liquids take the shape of container. Therefore, always liquids take the shapes of container. Shape of container. Shape of container. Third star mark. Third star mark. In gas physical state, gas physical state, gas physical state, gas physical state, weak intermolecule bonds between molecules. Weak intermolecule bonds between molecules. Therefore, weak intermolecule bonds between molecules. Therefore, they have very good flowing property. Therefore, they have very good flowing property as freely in the environment. They have very good flowing property as freely in the environment. As freely in the environment. Final star mark. In summary, liquids and gases, only consider about fluids, only consider as fluid. Liquid and gases only consider as fluids. Solid is not a fluid. Solids are not fluids. Solids are not fluids. Solids are not fluid. Okay, that's a very basic thing. I think you in depth you got in molecular level you have idea now. I think in molecular level different lessons in heat lesson in kinetic chemistry lesson, everything we discussed in molecular level what happening in how the expansion is, how energy transfer in molecular level, how chemical reaction how reactant convert into product in a molecular level. I think you everything you can now you have studied again and you everything you can remember now in very simply in fluids. I think you got the point. In fluid, if it is very strong bonds between molecules, it don't have flowing property. That's why we not consider solid as a fluid. Okay. Now don't write now, focus. Okay, now when we consider about fluids are according to the compressibility. According to the compressibility, fluids we can divide into two main types. Fluids we can divide into two main types. They are compressible fluids and incompressible fluids. In this lesson, we mainly discussed about both we discuss compressible fluid and incompressible fluid. What is the meaning of that? Compressible fluid. Compressible fluid. Compressible fluid and incompressible fluid. Incompressible fluid. Compressible fluid and incompressible fluid. Okay, can you imagine what is the difference between compressible fluid and incompressible fluid? Compressible fluid and incompressible fluid. Do you have any idea what's the difference between incompressible and compressible? Incompressible and compressible. Incompressible and compressible fluids. Incompressible and compressible fluid. Okay, that you can understand very simple experiment. I will explain. You want to get a injection cylinder, syringe, injection syringe. If you get a large one, you can get this. You can get super clear result observations. Okay, and you need to remove this. කටු අයින් කරන්න. Then you can see this side small opening you can see, and this one is a cylinder. This one is a cylinder. This one is a cylinder. Then you can see there is a rubber piston. No, there is a rubber piston, and there is a cap here. Okay, that's a small syringe. Okay, now first of all you need to without any liquid, we need to close this piston into this, and then in our atmosphere we need to get air into this cylinder. We need to absorb air into this cylinder, and by our finger or whatever object we need to close this end. From this end we need to close. After that we need to pressure this syringe. We need to pressure this piston. Then what happened? Is it compressed or not? Compressed වෙනවද නැද්ද? Is it compressible or not? Compressible or not? Yeah, simple answer. In your idea, is it compressing or not? Inside the syringe air. Yeah, normal environment air, atmospheric air. Okay, what do you think? Is it compressed or not? Compressed mean I asked this syringe is tight or not? Make a travel කරනවද නැද්ද? Is it traveling or not? The syringe is go this side or not? What do you think? Yeah, very good. For a certain extended gets compressed. Yeah, it's traveling, and after some point it is compressing. After some point it is compressing. It also has a specific reason. It also has a specific reason. I will explain. Okay, now the second part of the experiment, we need to get water into this same syringe, and we need to close this end, close this opening end, and we need to push a pressure on the piston. Then what you can observe? They are simple in small time your experiment. Okay, what's the observation? When we pressure with water inside the cylinder, water now, what happened? Inside the cylinder, water, what happened? Now it is very slightly compressed, and it is stopping. No, slightly compressed and stopping. But in when it is filled air, it is considerable value compressed and stopping. Compressed and stopping. In water, it is slightly compressed. පොඩ්ඩක් piston එක travel කළා, then it's become pressure, high pressure. Okay, now what is the reason? Normally that we call compressible fluid mean, understand now with this experiment you can understand. Compressible fluid mean when we apply external force or external pressure, when we apply external force or external pressure, if any matter change the volume, that we called as compressible fluid. When we apply external pressure or external force into some area, in this lesson we discussed any area, when we apply force, that we called as pressure. Okay, in this lesson up to now, think when we apply external force, when we apply external force, if it is the volume is changing, that we called as compressible fluid. Okay, then among liquid and gases, what do you think, which one compressible, liquids or gas? Compressible, liquids or gas, according to our experiment? Liquid or gas compressible? What do you think? Very good. Gases are the example for compressible fluid. Gases are the example for compressible fluid. Okay, now I think you can, in molecular level also, you can get idea. In gases, they are free molecules. And do you remember when I draw the structure of gases? When I draw the structure of gases, I told they are very weak bond between molecule, as well as they have more considerable value of intermolecular spaces. No, they have huge intermolecular spaces. That's why when we apply any external force, the spaces are recovering. The spaces are, volume is decreasing, then the molecules getting close. Molecules getting close, a close the piston is become tight. I think now you can understand. Okay, because of these higher, considerable, huge intermolecular bonds, when we apply external force, the volume is decreasing. The volume is decreasing, then the molecules are getting close. Molecules are getting close, that's why it's become pressure. Okay, it close and stopping the piston like this, stopping volume decreasing. Okay, now I think you can get the idea what is the meaning of compressible fluid. Compressible fluid mean when we apply any external force, the volume is changing. If their volume is changing, that we call as compressible fluid. Compressible fluid. Okay, what is the meaning of incompressible fluid? The opposite side. When we get water into the syringe and then we push, when we push, what happen? The always liquids are incompressible fluid. Liquids are incompressible fluid. Liquids are incompressible fluid. Okay, liquids are incompressible fluid. Why? The reason you already know. The reason is they are intermolecular bonds are medium. Intermolecular bonds are medium, but they are very close. Their molecules are very close. Still, they are not more spaces between. Therefore, I told in liquids, when we apply external force, or piston when we push the piston, it is slightly more into forward, then it is stopping. What is the reason? I told they have very low intermolecular spaces. They are very close to each other. They are not separated. In this one I explained, I think, remember. They are not separated. Like gases. They are very close each other. Then when we apply external force, the volume is decreasing very slight amount. But in our calculation, in our lesson, it is also very small compressible. The compressibility is very, comparatively, the liquid compressibility of gases are very high, but in liquids also very slight compressibility is there. But in our lesson, we consider every liquids are incompressible fluid, the amount of compress that we neglect. Are you clear? Are you clear? In our lesson, we consider all liquids are incompressible fluid, but in practically you already know in our experiment as well, the liquids also slightly compressible, but not like gases, but in our lesson we consider, the gases are compressible fluid and uh, liquids are incompressible fluid. Liquids are incompressible fluid. Now, practically, you need to know liquids also little compress, but slightly, very small amount. Then after their space is recovered, their space is finished, the molecules are already closed. Then it is incompressible after their space is reduced. Very small amount compressed liquids, but that we neglect in our calculation and our learning lesson. Okay, but gases, they are considerable spaces between molecules. Therefore, when we apply external force, its volume is changing. Okay, clear? Compressible and incompressible difference. Okay. Okay, write down next point. According to the compressibility, fluids are, according to the compressibility, fluids are mainly two types. According to the compressibility, fluids are mainly two types. First one, compressible fluid. Second one, incompressible fluid. First one, compressible fluid. The second one, incompressible fluid. Compressible fluid. Second one, incompressible fluid. Compressible fluid. Second one, incompressible fluid. Okay, write down the subtopic number 1, compressible fluids. Subtopic number 1, compressible fluid. Subtopic number 1, compressible fluid. Subtopic number 1, compressible fluids. Write down under compressible fluid, write down. When apply external force, if volume is not changing, this type fluids, if volume is not changing, this type fluids called as compressible fluids. Sorry, the volume is changing, not changing anyway. When apply external force, if the volume is changing, this type fluids called as compressible fluids. Example, gases. Example, gases. Write down with star mark. In below, write down star mark. In gases, huge intermolecule spaces between molecules. in gases huge intermolecule spaces between molecules. Therefore, when apply external force in gases, huge intermolecule spaces between molecules. Therefore, when apply external force, when apply external force, space volume is, when apply external force, space volume is decreasing. Space volume is decreasing. Therefore, when apply external force, the space volume is decreasing. Space volume is decreasing. That is the reason to consider gas is that is the reason to consider gas is a compressible fluid. That is the reason to consider gas is a compressible fluid. Okay, I'm giving the note in very simple way to your later future understand. If you read now, you have full idea about the basic. Still we are very basic level. I'm giving the introduction of this lesson. Still we not start. If you go to the tute is not given anything. The tute, our syllabus is starting from static and dynamic fluids, but I'm not going to start from this level, because otherwise if you don't know in I know in O level time you don't know more these things in O level time, as I guess. Am I correct? In O level time you not learn more about fluids, no? Very small H rho G, like very small things you discuss, as I remember, I think. I don't know your new syllabus, I don't know, but in our time it's very simply they explain in fluid mechanism in O level. But in today we are going to discuss it is maximum level we are going to discuss. Okay, Uri theorem we discussed. In this lesson we discuss about the Pascal theorem, Archimedes theorem, Bernoulli's theorem, different relationships, everything we're going to discuss now. Now you must have a 100% idea about this. Even in molecular level you must have an idea. Okay, write down subtopic number 2, incompressible fluids. Write down subtopic number 2, incompressible fluids. Incompressible fluids. Incompressible fluid. Subtopic number 2, incompressible fluid. Write down when apply external force. When apply external force, if the volume is not changing, if the volume is not changing, if the volume is not changing, this type fluids called as incompressible fluids, called as incompressible fluids, incompressible fluid. Example, liquids. Example, liquids. Example, liquids. Example, liquids. Write down with star mark. In liquids, intermolecule spaces are very low. In liquids, intermolecule spaces are very low. Therefore, when apply external force, in liquid, intermolecule spaces are very low. Therefore, when apply external force, the volume is slightly changing. The volume is slightly changing. The volume is slightly changing and stopping volume change. And stopping volume change. Stopping volume change. Stopping volume change. But in our studies, but in our studies, slightly volume change in liquid, slightly volume change in liquids, slightly volume change in liquid is neglecting. Slightly volume change in liquid is neglecting. It is that is neglect, then we consider is neglecting. Therefore, final point, every liquids consider as incompressible fluid in this lesson. Therefore, every liquids consider as incompressible fluids in this lesson. Therefore, every liquids consider as incompressible fluids in this lesson. Oh, sorry. Give me a second. There was a light problem. Can you repeat the point? I lost the connection. Which point, Teva? Which point you want? Which point? This point, this stomach. Okay. Yeah, actually, I don't remember which part you miss. Okay, I'll send today note into the group. Then you can complete. I can't remember now which part you miss. I can't find now. I'll send today written note into the group. Okay, I'll find a note and I'll send. Okay, keep 2 or 3 rules and note down. Okay, now I told you there are fluids mainly 2 types: compressible fluid and incompressible fluids. Uh, compressible fluid mean when we apply external force, the volume is not changing. Do you already know gases is a incompressible fluid. Incompressible fluid mean when we apply external force, the volume is not changing. Compressible mean volume is changing. The incompressible mean volume is not changing. Then you know liquids, their molecules are very close, only very slightly compressible. In our lesson in physics, that we not consider, that is neglecting. Okay, that is the full summary of the basic parts of the liquids. You already know. Now I will give you summary. Now up to now we discussed, from the part of up to now we discussed, that's a summary. Okay, when we consider about fluids, sorry, physical state of matters, can start from here. Physical state of matters. We divide it into 3 main types: solids, solid, liquid, and gas. I told among that liquid and gases we called as fluid. Liquid and gases we called as fluids. They are the fluids. Now fluids are divided into 2 main types. So it's divided into 2 main types. They are compressible fluid and incompressible fluid. Incompressible fluid. Okay, examples for compressible tube. Examples for compressible fluid, it is gases. Example for incompressible fluid, example is liquids. Okay, that's a full summary up to we discuss. This is a full summary of our today discussion, the basic part of the fluid lesson. Any doubt you can ask. Any doubt you can ask. 7 to 8, 1 hour this is the full discussion of the this hour. 7 to 8 we got for this small part discussion. Okay, now if you have this basic knowledge, now we can go for our lesson. Any doubt you can ask. Any doubt you can ask. Everything clear? Yes or no? Everything clear? Arshad? Okay. Okay, can anyone send me not need me if anyone able, please if you complete note, take photograph and upload the group, then others if any uh, point miss you can complete. Okay, who can do this note? Who can send to the group? All I think complete note, no, only one. Arshad, are you complete note? Arshad complete ne? Then take photo and send to the group. If you can now also. Okay, okay, now we go into the our next part. Actually now we go into the lesson. Still we did the basic part. Now we going to start our lesson. Actually in this lesson we mainly discussed about fluids. Now you already know fluids mean liquid and gases. Fluids mean liquids and gases. Okay, now in this lesson, we mainly discussed about two main fluids types. Now fluids mean liquid and gases, that we already know. Fluids mean liquid and gases. Now fluids, we mainly discussed in this lesson two type of fluids. Now not compressible and incompressible. The fluids in this lesson we divide into two types: static fluid and static fluid and static fluid and dynamic fluid. Static fluid and dynamic fluid. Static fluid and dynamic fluid. Okay, what is the meaning of static fluid? Do you have idea? What's the meaning of static fluid? Static fluid. Okay, what's the meaning of static? Not static fluid. Static fluid. You know, yeah, do not moving. It's the position is not changing. Yeah, very good. Yeah, yeah, motionless. Yeah, that's the meaning of static fluid. Actually, the static fluid mean fluid in a container like this, like a water tank. Water tank. That's the meaning of static fluid. Static fluid. Dynamic fluid mean like a river. Like a river. The water is flowing. Like wind. 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 You know, the wind is a now this dynamic fluid can be compressible or incompressible. It can be liquid or gas. If it is river is flowing, that is a incompressible fluid dynamic. In the wind, like the wind is a compressible fluid dynamic. Okay, that we can discuss later. Differences, everything we can discuss later. Now I think you can understand difference between static fluid and dynamic fluid. Static fluid means the fluid is not moving, it is a rest fluid in a container. In a container, dynamic fluid means flowing fluid, flowing or moving liquid or gas. That's a fluid. Okay, in this static fluid, now we are going to listen. In this static fluid, we mainly discussed about these topics. The first one is density. In static fluid, we mainly discussed about density. In second one, we discussed about relative density. I think all level time also these things you have done, you have learned earlier. Relative density. Relative density. Relative density. The third one, oh, some part is cutting. Okay, now. Okay. Relative density. Our second topic is under static fluid, relative density. Our third topic is pressure. Pressure. Normal pressure. Okay. Our fourth topic is hydraulic pressure. Hydraulic pressure. Hydraulic pressure. Our fourth topic is what our fourth topic? Atmospheric pressure. Atmospheric pressure. In short, we called it is ATM pressure. ATM pressure. Atmospheric pressure. The sixth one is what? Pascal's theorem. Pascal theorem. Pascal's theorem. Pascal's theorem. Pascal's theorem. Our sixth one, sorry, seventh one. Our seventh topic is Archimedes theorem. Archimedes theorem. Archimedes theorem. Every theorem and their applications working. Archimedes theorem. Archimedes theorem. Archimedes theorem. The final one, eighth topic is the buoyancy point. Mainly we discussed about buoyancy point. Buoyancy point. Buoyancy point and gravity point equilibrium we discussed under in this the final part. The final part is very interesting. In the final part we discussed how boats are without turning parallel how boats are moving in a water. Everything we discussed. The other thing is, you know, every boats, ships, they are made from irons, no? But if we add any iron part into water, then it is go down. But the then the ships and boats produced from iron, it is flowing. We need to discuss what are the reasons, everything. That's a very interesting lesson. After we discuss basic part, if you got maximum idea about this basic part, full idea about this basic part, the final parts are very interesting. We discussed all applications. Okay, these parts are very interesting if you understood this basic part first. Okay, okay, in this dynamic fluids, mainly first topic is turbulent and laminar flow. That's mean laminar flow. Turbulent and laminar flow mean in dynamic fluids, the fluids are flowing. There are different types of flowing types. We discuss different types of flowing types. The turbulent is a one type, laminar flow is another type. But in this lesson we mainly discussed about laminar flow. The turbulent is, I think I will give you small idea. Turbulent mean moving like this. The laminar flowing, it's moving like this. That's the difference. Every characteristics, their exam questions also there in the this part. What are the difference between laminar flow and turbulent flow? Explain the difference between laminar flow and turbulent flow. Then what you can comment about the uh, uh, moving velocity. In this lesson, we discussed about steam tube and what other one is steam line. Okay, steam line. Okay, everything we need to discuss in this lesson. Okay, part by part, if we can discuss part by part as we discussed up to now. Okay, the second topic is steam line. Steam line. Steam line is a part of this flow. Okay. The third one is steam tube. Steam tube, they are very simple subtopics. Steam tubes. The fourth one is continuity equation. Continuity equation. Continuity equation. Okay, that's the lesson. Finally, we discussed about Bernoulli's theorem. That's the main one. Bernoulli's theorem. Bernoulli's theorem. Bernoulli's theorem. And as final part, we discussed about application of Bernoulli theorem. Application of Bernoulli theorem. That's a full summary of the lesson. That's a full summary of the lesson we going to discuss. If we complete these 8 topics, then static fluid is complete. After that, we move into dynamic fluids. If we complete these 1, 2, 3, 6 topics and application of this Bernoulli's theorem and application of other all theories, then the fluid mechanism is completed. Okay, if you want, write down topic static and dynamic fluids. Static and dynamic fluids. Write down topic static and dynamic fluids. Static and dynamic fluids. Static and dynamic fluids. After topic, better to draw this chart. Then you can get idea about where we discussed in this lesson. Then you can easily understand this lesson if you know the path we going. Okay. Now we are going to start the lesson. Before that, please note down that in your extra paper. Okay, extra paper. From this point, every note is contained in your tube. The final in dynamic fluid, the final one is application of Bernoulli's theorem. Application of Bernoulli's theorem. Application of Bernoulli's theorem. I complete. Okay. Now write down the topic static fluid. Write down the first topic static fluids. Write down the first topic static fluids. Okay. Every note is available in the tube, but I will give you short note, very short note. I will give you. If anything extra thing, if you need, you can read the tube. Your printed tubes within 2 to 3 days, it will receive to your home. Then you can read that. Or it contain few spaces. You can complete them only with the first part. In from next week you have tubes, then you can complete at the same time, no issue. Okay, now this lesson is like not a theory lesson, that's a rational understanding and calculation lesson actually. Therefore I will give you a very short note, then you can note down. Only I will give you definitions and only important few points I will give you, then you can note down, and that's attached with your printed tubes, then you have complete tubes. Okay. Okay, write down the static fluids. Static fluids. Static fluid. Static fluids. Static fluids. Write down first topic. First point. Write down first point. Flu, sorry, fluids in a container. Fluids in a container, or fluids in a container, or non-flowing fluids. Non-flowing fluids consider as static fluids. Consider as static fluids. Non-flowing fluids consider as static fluids. Static fluids. Static fluids. Okay, write down the first subtopic under static fluid, the density. Density. The density. First subtopic under static fluid. First subtopic under static fluid, the density. Okay, now I think all over time you already know what is the meaning of density. What is the definition of the density? I need answers in your side. What is the definition of density? Density. What is the definition? What is the definition for density? Yes. Simply, if you got think if we got one whatever matter, think iron or whatever metal, if you got 1 cubic meter cube like this, 1 cubic meter cube, 1 cubic meter cube, that means the length is 1 meter, the width is 1 meter, 1 meter, the height also 1 meter. Then you can see the volume of this cube we called as the volume of this cube we called as the, it is 1 cubic meter. 1 cubic meter is the volume. 1 cubic meter is the volume. Simply understand, they are very basic things. Very basic things. It is a 1 cubic meter cube of whatever metal or whatever matter. Okay, if we get the mass of this, if we get the mass of this cube, if you got the mass of this cube, this is the, then think the mass of this cube is 500, no, 1.5 kilogram, 1.5, 1 cubic meter, 1 cubic meter volume, mass is 1.5 kilogram. Example, then we can say the volume of this object, sorry, the density of this object is, density of this object is 1.5 kilograms per cubic meter. 1.5 kilograms per cubic meter. Now you can understand the density of any matter is the mass of the unit volume. Then this is 1 cubic meter is a unit volume. It is a unit volume. The volume is 1. The volume is 1 in standard unit. That's the meaning of 1 cubic meter. That's the meaning of 1 cubic meter. Then the mass of unit volume, yeah, you all are correct. The mass of unit volume that we called as a, practically understand, if you got a unit volume, whatever 1 cubic centimeter or 1 liter or whatever unit volume, the mass we called as the density. The mass we called as the density. I need the practical understand. Practical understand. The if we get a unit volume, whatever unit volume, its mass we called as a density. Mass we called as a density. As example, if we got water, if we got water, water is, you already know, I think, water. If we collect one meter length, 1 meter width, and 1 meter height, if you got a water tank, if you filled full water, the mass of this water amount is, remember, 1000 kilogram. I think you already know, 1000 kilogram. Then we can say the density of the water is 1000 kgm minus 3, kgm minus 3, not 2, minus 3. Then the unit is kilograms per cubic meter. Kilograms, cubic meter එකක කොච්චර mass එකක් තියෙනවද? The mass of unit volume that we called as the density. The density means the mass of unit volume. Mass of unit volume. I think I got this example for you understand. Now you can understand the mass of unit volume of any matter. Of any matter we called as the mass of unit volume of any matter we called as the density. The density equal density we can calculate by mass of the object, mass of the matter dividing by the volume. Dividing by the volume, you already know when we divide by any quantity, it's become one. Divide karne ka ekak වෙනවා, that's we called as mass of unit volume, that we called as the density. Then in short form we can say the density equal the m over v. The density equal m over v. Sorry, not capital D. Sorry. This simple. Density equal m over v. Density equal m over v. Then we can, the unit of the d, the units, density units, the standard unit you need to remember, kg, m cubic meter. When it is come up, it's become -3. This is the standard units, that they are the things you need to remember under density. Any doubt? Understood? The first thing, first subtopic, the density I got. Okay, write down the mass of unit volume of any matter. The mass of unit volume of any matter is called as the density. 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 Okay, then note down density equal mass over volume, D equal M over V, D units kg ms minus 3, D unit mean density units. The kg m minus 3, the kilograms per cubic meter. Okay, kilograms per cubic meter, that's a standard unit. More than, that's a standard unit. That's not only unit, there are different types of unit. G cm minus 3, grams per cubic centimeter, kg cm minus 3. There are different types of units. They are the liters per, sorry, kilograms per liter. They, different types of unit, they are the most, that's a standard unit. And other than that, that also we probably using gcm minus 3. I think in O level time you familiar these units. gcm minus 3 mean grams per cubic centimeter. Grams per cubic centimeter. Are you done? Complete? Okay, we'll move into few questions, small questions. Okay, question number one. Question number one. Yeah, this one is the kg m minus 3 is the standard unit, but this one also we use probably, but it's not the standard unit. It's not a standard unit. This one is standard unit. Okay, the kg m minus 3 kilograms per cubic meter is the standard unit, because the mass standard unit is kilograms, volume standard unit is cubic meter. But if you want, we can get the mass from gram and volume from cubic centimeter. That's also g cm minus 3, but that also we using, but it's not the standard. As example, to get the length of the length එක මනින්න අපි meters විතරක් නෙමෙයිනේ ගන්න. If you want, we can use centimeters, kilometers we can use, but they are not standard. The standard one is this, but this also using. Question number one. Okay, sorry. Question number one. Question number one. Question number one, where we start. Starting from very easy one. No? Mm, yeah, write down like this. Very easy one. Yeah, I try to give another one, but it's little difficult. Advanced. We'll try it as second question. Okay. First one. The mass of the mass of the mass of two cubic meter of the mass of 2 cubic meter of iron cube is 20 grams. Calculate the density of this. Calculate the density of this iron cube. Iron cube. Calculate the density of this iron cube. Okay, very simple question. It's only 20 gram. 20 gram. Then get the answer and send me. Answers. Yes, it's very small value, no? The density equal mass over volume. The density equal the mass, you can't substitute with kilograms, then 20 need to divide into 1000. Divide by the volume is 2 cubic meter, it's no problem. 2 cubic meter, it's no problem. The density equal 0 to 0 cancel out, then 0.02 divide by 2, the density equals 0.01 kgm minus 3. 0.01 kgm minus 3. 0.01 kgm minus 3. Very good. All are correct. 0.01 kgm minus 3. 0.01 kgm minus 3. Complete. Question number 2. Question number 2. Question number 2. Can I erase? Question number 2. Question number 2. 500 cubic centimeter. 500 cubic centimeter. 500 cubic centimeter of unknown solution. Unknown solution was used for an experiment. The mass of the solution, was found as 200 grams. Calculate the density of the unknown solution. Density of the unknown solution. Yeah, simple question, same as previous, only small difference. Calculate the density of the unknown solution. Unknown solution. Okay, they are possible MCQ questions, simple questions. Only unit conversion only. The equation is same. The density equal M over B, but you can't substitute given units. All unit must be converted into standard unit. That's a task. That's a task in this lesson. Lot of unit conversion you need. Otherwise, you can't do this lesson. Unit conversion is must for this lesson. Yeah, we'll try. I think different answers. We'll try. We'll see. Okay, the mass is 200 grams. If I directly convert into kilogram, it is 0.2 kilogram. 0.2 kilogram. It's easy. 0.2 kilogram. Then the volume is, now the volume is problem. The volume is given in cubic centimeters. Cubic centimeters. If it is given in cubic centimeters, what you need to require? We need to require that convert into cubic meter. Cubic meter. Then cubic meter, how we convert centimeter into cubic meter? Sorry, centimeter into meter. Dividing 100. Now 500 need to divide in 100 to convert into meter. Now it is converted into cubic meter. Then we need to again multiply 100 and again multiply 100. I think we same thing we did in previous questions as well. Then 20 we can cancel out. Then 0.2 kilogram we can divide into 1, 2, 3, 4. 0.0005 cubic meter. I think all are wrong. 0.2 over 0.0005. What is the answer? That means 2000 over 5, no? 2000 over 5. Yes, 400 kg m minus 3. Yeah, one answer correct as I remember. Amavi correct. Very good. Others wrong. You can't substitute by cubic centimeters. Need to convert. Need to convert. Now understood, Amar? Ashar? Okay. Question number 3. Question number 3. They are not A-level question, like O-level question. Okay. Question number 3. Calculate the question number 3. Calculate the mass of, calculate the mass of 5 liter of water. Within bracket, the density of water 1000 kg m minus 3. Okay, simple question. The density of water is given 1000 kg m minus 3. The question asks calculate the mass of 5 liter of water. 5 liter of water. Okay, quickly I need answers. You can use same equation if you want. If you want without equation also, you can directly get the answer. Any method. Are you done? Actually, no need to calculate, no? Yes, actually no need to calculate. If you know the theoretically, you know it is answer must be 5 kilogram. Answer is 5 kilogram because that's only you need to remember. That's a very important compulsory point you need to remember. If you know this, you can get the answer. You need to remember one cubic meter of any liquid, it is 1000 liter. If it is water, if it is coconut oil, if it is whatever petrol, 1 cubic meter, it is 1 liter. Sorry, 1000 liter. 1 cubic meter mean, imagine 1 meter length, 1 meter width, 1 meter height tank. It can fill 1000 liter of any liquid, but when we fill this 1000 liter, its mass is changing. According to the mass, we consider density. The according to the mass, it depends on the density. Okay, now the 1 cubic meter equal 1000 liter. Now the question given, the density of water, it is kg, 1000 kg m minus 3. The density of water, it is 1000 kg m minus 3. Kg m minus 3. The meaning is within 1 cubic meter, within 1 cubic meter, within 1 cubic meter, 1000 kilogram. Within 1 cubic meter, 1000 kilogram. Water 1 kilogram, the mass is, sorry, with water 1 cubic meter, the mass is kilogram, 1000 kilogram. Then 1 cubic meter equal to, you already know 1 cubic meter is equal to the 1000 liter. Then we can say 1000 liter equal to the 1000 kilogram. Then 1 liter equal to the 1 kilogram. 5 liter equal to the 5 kilogram. No need more calculation. 5 liter water equal to 5 kilogram. That's one method. Without any equation, you can only unit, you can using unit, you can get the answer. In other side, if you use equation, the density equal the mass over volume. The density equal mass over volume. The question asks the mass of, the question asks mass, no? Then the density is given. The density is 1000 kgm is kgm minus 3. 1000 kgm minus 3. The mass is given. Mass is asking. Mass is asking. The volume is given. Volume is given in, it is 5 liter. 5 liter. Do you remember how we convert 5 liter into, now we, for this equation, we need to substitute standard units, no? The liters we cannot substitute kgms minus 3 equation because the density is given with kgms minus 3. Then you need to substitute the volume with cubic meter. Now the question given 5 liter. How we convert 5 liter into cubic meter? I told 1 cubic meter is 1000 liter. Then if I divide this into 1000, then you can convert this liter value into cubic meter. Now it is cubic meter. I think you got. Then the mass equal cross multiplication. Cross multiplication, 1000 multiply 5 over 1000. 1000 to 1000 cancel out 5 kilogram. Any methods you can use. Any method you can use. Are you got? All are clear? Any doubt you can ask. Okay. Question number 4. I think you all are complete. Question number 4. Question number 4. Calculate the mass of, calculate the mass of 3 liters of coconut oil. Calculate the mass of 3 liters of coconut oil. Coconut oil. Coconut oil. The density of coconut oil. Density of coconut oil. The density of coconut oil. 870 kgm minus 3. 870 kgm minus 3. The density of coconut oil 870 kgm minus 3. Okay, you know, the when we add water and coconut oil together, coconut oil is flowing in water. That means the water density is higher than coconut oil density. Okay, get the answer and send. Any method you can use. Yes, very good. 2 point value, no? Tevan, what's the value? Very good. Yes, all are correct. It is 2.61. Yeah, I will edit this one. It is easy, no? Now, the density is given 870 kilograms per cubic meter. Then the mass is asking. The volume is given in liter. Then 3 liter we need to convert into cubic meter dividing 1000. Then the mass equal 870 multiplied by 3 over 1000. 0 to 0 cancel. Then the m equal 2.61 kilogram. This is the answer. This is the answer. 2.61 kilogram. You can don't remember any every liquids 1 liter equal to 1 kilogram. 1 liter equal to 1 kilogram only for pure water. You need to remember our drinking water also density is not 1000. Only pure water. Pure water means distilled water. All ions after removed, after filtered, this water only 1000 density is 1000. Others are with minerals density is changing. Okay. Okay, give me second. Okay. Okay. Now that is the density. The density mean you already know the mass of a unit volume. Mass of a unit volume that we called as the density. Very simple. The mass of a unit volume of any matter, that is the density of this matter. The mass of a unit volume, that is the density of this matter. Okay, now we going to discuss, we going to move into our second topic, that is relative density. That is relative density. Write down the second topic, relative density. Relative density. Relative density. Relative density. Relative density. Okay, in only in word, I think you can get idea about the name. From name, the relative density. Relative density. Is there any idea? Relative. In Sinhala, සාපේක්ෂ ඝනත්වය. Relative to, normally the density relative to, සාපේක්ෂව, for non density. The density of any matter relative to another non density that we call as non already known matter density relative to this one. That when think this liquid density relative to this already known one. Normally already known, as already known density, we consider it is water density is the already known density. Okay, then the relative density is the ratio, that the definition is the ratio between the matter density and water density. The density of any, the actual meaning is the density of any matter relative to the water density. The density of any matter relative to the water density. I told always the relative densities take with relative to non density. The non density is water density in this. The relative density relative to the water density. The water is the non density. Then the density of any matter relative to the water density is called as the relative density. Is called as the relative density. The density of any matter relative to the water density. Then that we called as the ratio between matter density, the density of any matter divided by water density. Okay, then we can get the relative density. Relative density, I will get in short form, relative density equal matter density. Density of any matter density divided by water density. Water density. Okay, simple question. If I ask, think there is a matter, there is a liquid solution, its relative density is 2. Then what is the relative densities? Before that, before this question, what is the unit of relative density? Unit of relative density. Quickly, what is the unit of relative density? Any idea? Unit of relative density? Very good. It don't have unit. Why? The matter density is kgm minus 3, kgm minus 3, kgm minus 3. It is density. It is a density. The water density also kgm minus 3. This one cancel out. Then relative density don't have units. Relative density don't have units. Relative density don't have units. Okay. Okay. Now my question. There is a solution. Its relative density value is 2. Relative density value is 2. Relative density value is 2. There is no units. It's 2. Then what is the density of this solution? What is the density of this solution? The relative density value is 2. What is the density of this solution? Simple question. No, Tevan. Tevan wrong. First understand the meaning. The relative density means the density of any matter relative to the water density. ඒ කියන්නේ water density වගේ කී ගුණයක්ද කියලා අහන්න. How many times like water density? Then the relative density is 2 mean the water density is 1000 kgm minus 3. Relative density is 2000 because the matter density is 2 times like water density. Everyone understood? It is 2 times. That's the meaning. That's the meaning. Relative density, if it is relative density 0.5, now 10, the relative density is 0.5. Then what is the matter density? Solution density. Very good number. Devan, what is the solution density? I am asking the relative density 0.5. Now relative density. Now if it is relative density 1, what is the matter density? The relative density is 1 mean it is equal to water density. Then if it is 2, it's 2 times like water density. If it is 5 times like water density. If it is 0.5, 0.5 is half, no? Then if it is half from the water density, then it is 500 kgm. Any doubt? Yes. Yes, good. Okay, I think if you want very short method is to get, if you know the relative density, of any matter, the water density is constant, no? Water density is always 1000 kgm minus 3. Water density is 1000. Then relative density is 2. You can see cross multiplication, then matter density you can get. Then relative density is 0.5. 0.5 means half, multiplied by 1000, it is 500. Okay, that's simple equation. No? This is a simple equation. Okay, write down this short note and then we can go 1 or 2 question and go to the next parts. Okay, write down everything is that enough. The density of any matter relative to the water density is called as the relative density. Relative density equal matter density divided by water density. Units, no units. Okay, write down this. Okay, question number one. Question number one. Calculate the volume of calculate the volume of 20 kilogram of 20 kilogram of calculate the volume of 20 kilogram of calculate the volume of 20 kilogram of a liquid with relative density 0.75 with relative density 0.75 within bracket provide final answer in liters. Provide final answer in liters. Okay, now you can try. That's a simple question. Now if you know, you already know the density and relative density both. Now you can try. There is a liquid, its relative density is 0.75. The question asks what is the volume of 20 kilogram of this liquid uh, in liters. Any answer? Repeat the question. Calculate the volume of a liquid. Calculate the volume of 20 kilogram of a liquid with relative density 0.75 within bracket. Provide answers in liters. Provide answers in liters. Good. Okay, we try. Okay, first of all, the question given, the relative density value is 0.75. Then first of all, we need to the unknown liquid, its density. Now we can find its density is relative density value multiplied by water density. Then we can get we can say 750 kg m minus 3 is the 750 kg m minus 3 is the density of this liquid. First of all, we can find this 750, the relative density value I multiplied by the water density. Then we can find the density of the liquid. Now the question asks not density, the volume of 20 kilogram. 20 kilogram of now the density equal m over volume, mass over volume. Now the question given, the density is 750 according to our calculation, kg m minus 3. The mass is given, sorry, the mass is given, it is 20 kilogram. It is 20 kilogram. Now the volume is asking, but in this equation, the volume is coming in cubic meter according to the unit. The standard unit again tamai. Then first of all, we need to find the volume in standard unit. Standard unit 750 multiplied by 20, 0 to 0 cancel. Then 75 over 2, the volume is 75 over 2, no? No. 2 over 75. 2 over 75. Very small value, no? The volume in cubic meter, what is the value? 0.0. No, actually, don't need 2 over 75 also we can use. 2 over 75 cubic meter is the answer. Okay, but this value from cubic meter. But the question asks the question asks from liter. Now you already know 1 cubic meter means 1000 liter. Then if I multiply this value from 1000, you need to remember, that's very carefully remember, liter convert into cubic meter divide by 1000, cubic meter convert into liter multiply by 1000. That is simple, like meter centimeter conversion. Then the volume in liter 2 over 75 multiplied by 1000, then it is converting to, then 2000 over 75, the answer is 2000 over 75, the answer is 26.67. 26.67 liters. Okay, this type MCQs are most possible question in the exam. Very simple, only 2 steps. Actually 3 steps. First of all, you need to find the density of the liquid by the relative density. Then you need to calculate the volume by in cubic meter. Finally, you need to convert into liters. Okay. Okay. Are you tired? 9:30 now. I hope to complete today up to some pressure as well. Pressure and if we can complete up to pressure and hydraulic pressure and atmospheric pressure, then we can go to the advanced parts in the next day. What do you think? If we can discuss more 1 hour, we can complete up to pressure part as well. Pressure, we have 3 parts. The normal pressure means the commonly we discuss about pressure, then finally we discussed about, sorry, second part is hydraulic pressure, and the third one is about atmospheric pressure. Okay, what to do? Yeah, take a break and we'll continue, no? Continue now. 9:30 you need to eat, no? 20 minutes, 20 minutes. Then if I complete up to pressure pressure part complete, then within next day we can complete the static fluid, we can complete. Then within 1 day we can discuss the dynamic fluid. Then within 3 days the lesson is complete. Okay, take break. We'll start again 9:50. 9:50. 9:50. Okay, this is your. Can you hear me? You can, no? Yes. This is your. You have more 131 days to the exam. Accurate. November 10. Probably you exam not. It will, I think, starting from November 12 or 30. Then approximately you have 133 days. That's time enough. Normally for working you have 100 days, still you have 100 days for working. Final 30 days, 33 days, if we remove, you have still 100 days to work hard. 100 days mean you can change your result completely. You can change if you work, if you manage this time very well, you can turn your result into totally, you can different, you can totally, you can change your result. Therefore this is most important time. This is this 100 days of final 30 day. Don't forget about final 30 day. 30 day final month, that means October 10th to November 10th, forget about. Before that you have 100 days. Try to complete your all works. All works mean not only SFT, ET and ICT and other all subjects. You need to complete all works within, you have another 100 days. You have 100 days. Try to complete. Okay, if you complete very, very with if you work, if you manage this 100 for these 100 days very well, you can go to the exam with super good confident level. Okay, I will explain. If you come, if you work well these 100 days, these 100 days, in final 30 days, I'll give you, I'll guide you how to do, what to do, and what, how you need to manage the final days. Okay, you need to work, you need to work very hard, you need to manage your all three subjects within these first 100 days now. Okay, go to the lesson. Okay, 1 second. Okay. Okay, in the static fluids, we discussed up to density and relative density. Okay, our third one is pressure. Our third topic is pressure. Write down the topic, pressure. Third topic is pressure. 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 Third topic is pressure. Okay, what do you think? What is the meaning of pressure? Now you already know what is the meaning of pressure. In simply, what is the meaning of pressure? Give some like actually pressure gives some external force on any object on any surface. That's the meaning of pressure. Okay, now what is the scientific definition for pressure? What is the scientific definition for pressure? What is the scientific definition for pressure? What do you think? The scientific definition for pressure is, the scientific definition is, when we apply, think this is 1 meter, 1 meter, whatever surface. Okay, the 1 meter, 1 meter, that means the area of this plate is, think it is 1 square centimeter. The area of the plate is 1 square centimeter. Then if I put perpendicular force on this 1 square centimeter, if I apply perpendicular force, mean, I think you already know, this is the surface with surface 90-degree angle. The with surface, think this is a surface with surface, the force must be 90-degree angle. 90-degree angle. Then if I apply, think 1 Newton external force, 1 Newton external force on 1 Newton external force on 1 square centimeter, 1 square meter area, this pressure that we called as 1 Pascal. 1 Pascal. I think now you can understand. Therefore, the pressure is, remember, pressure is the perpendicular force. The perpendicular force. This word must include the perpendicular force act on unit area. Remember that the perpendicular force act on unit area, that we called as the pressure. The perpendicular force act on unit area. The perpendicular force, always the force must be perpendicular to the surface. If it is angle, it's not a pressure. We always need to get the perpendicular force to the surface. Then the force applied for unit area, perpendicular force applied for unit area, that we called as the pressure of any surface. Pressure of any surface. Okay, now how we get the pressure? What is the equation? The pressure equal normally, do you know there are two main factors affect on pressure? The two factors is the external force, perpendicular force, and area. External force and area. When we consider about pressure, the pressure is, remember that pressure is directly proportional to the this perpendicular force. That means when increase the force, the pressure is increasing. But when increase the surface area, it is decreasing. The pressure is decreasing. We can discuss applications. Then we can get the pressure, the final equation. The pressure is equal F over A. Perpendicular force divided by the surface area. This is the pressure equation. The perpendicular force divided by surface area. Then what is the unit of pressure? What is the unit of pressure? What's the unit of pressure? What's the unit of pressure? Very good, but the Pascal is the standard unit, correct? But the actual unit is Newton, force Newton divided by square meter. Force Newton divided by square meter. Then Nm minus 2 is the unit. That's the unit. Newtons per square meter. Newtons per square meter is the unit. Newtons per square meter is the unit. But for our the respect for the scientist that who found the this theory, uh, this theory is, then we consider 1 newtons per square meter is equal to 1 pascal. 1 newtons per square meter is equal to 1 pascal. Then we consider standard unit is pascal. The standard unit for pressure is pascal. The standard unit is pascal. Okay, that's all the basic of the pressure. Then we going to discuss now, before we'll try to complete before 11 up to atmospheric pressure we can complete. It's better then next week we can start from Pascal's theorem then. Okay, the pressure is the pressure, about pressure, full knowledge required for discussed about Pascal's theorem. Otherwise Pascal's theorem you can't understand. Pascal's theorem and the applications calculations you can't do without proper knowledge about the pressure, every type of pressure, not only simple pressure. Okay, write down the perpendicular force act on unit area. The perpendicular force act on unit area called as the pressure. Called as the pressure. It's called as the pressure. If you want draw this, then write down P. Yeah, P directly proportional to the F, P inversely proportional to the area, then P equal F over A. The unit is Pascal. Write down. Complete. Completed. Not yet. To complete send message, okay. Okay, we'll do go to a question. Okay, question number one. Question number one. $20 Newton perpendicular force. 20 Newton perpendicular force is act on a 20 square centimeter surface. Calculate the pressure generated by generated on the surface. Okay, quickly calculate. Pascal. 1 Pascal. I think now you. Yeah, what are the answers? Yes, I think correct. It is 1 Pascal. No, no, wrong. 7, wrong. Completely wrong. Uh, Pressure equal external force divided by the surface area. It must be perpendicular force. Perpendicular force divided by surface area. Then the meaning is the perpendicular force act on a unit area. The perpendicular force act on a unit area. And the force is 20 Newton. That's okay. Then you can't substitute as area 20. Is it possible? Is it possible to substitute? No, because then the answer is coming 1 newtons per square centimeter. Then is that a standard unit? No. Then we can't say n cm minus 2 as Pascal. The nm minus 2 is the Pascal, equal to Pascal. Then completely wrong. First, therefore, we need to convert this 20 square centimeter into 20 meter. Sorry, into square meter. Very good. Arshad, correct. We need to divide into 100, then it is converted into meter. Multiply by 200 into 100, then it is converted into cubic meter. Same as previous. Previously also we did same thing. Okay, now 20 multiplied by this 10,000. 10,000 over 20. Because this one I got as opposite direction. Then 0 to 0 cancel out. 20 into 1000. 20,000 divided by 2, it is 10,000. 10,000 Pascal. 10,000 Pascal. Everyone understood? How we decide it is 100 එකක්ද දෙකක්ද තුනක්ද කියලා? How we decide? 1 or 2 or 300? That depend on the, if it is square centimeter convert into square meter, we need to divide 100 into 100. Cubic centimeter convert into cubic meter, we need to divide 100 into 100 into 100. Three times. Okay, question number 2. Question number 2. Draw this one. Draw this one. Draw this one. Write down 50 Newton perpendicular force. 50 Newton perpendicular force act on a 50 Newton perpendicular force act on a 7 centimeter radius piston. 7 centimeter radius piston is given in the figure. Is given in the figure. Is given in the figure. Calculate the pressure generate on the piston. Calculate the pressure generate on the piston. Calculate the pressure generate on the piston. Fifty centimeter, sorry, 50 Newton perpendicular force act on a 7 centimeter radius piston is given in the figure. Calculate the pressure generate on the piston. Arshad, complete. Quickly send answers. Very simple questions. Yes. Different answers. Okay, we'll try. Okay. This is a perpendicular force. Therefore, the pressure equal the F over A. Then the perpendicular force is okay. It is 50 Newton now. 50 Newton now. It is 7 centimeter mean the 5 r squared. 5 mean 22 over 7. R squared means 7 into 7. 7 to 7 cancel out. 22 over 7, 100. 154 square centimeter. It is centimeter. Now we want to convert again into meter. Again we need to convert into meter. Very good, Tevan. Then it 100 into 100 වලින් බෙදන්න ඕන. Then the answer is coming 3246, no? 3246.75 Pascal. Yeah, now correct. All are correct. Okay, simple. Okay, final question. Final question. Final question. Okay, what to do now? Okay, the question number 3, as I remember, question number 3. Question number 3. Draw this figure and first draw this figure, then I will read the question. Calculate the pressure generated on above piston. Calculate the pressure generated on above piston by 100 Newton force, by 100 Newton force, 30-degree angle to the horizontal axis. By 100 Newton force, 30-degree angle to the horizontal plane, horizontal axis. Okay, your chance. Very good. Okay, this one same. First of all, you need to get the piston surface area. Piston surface area is 5r squared. No, that's a circle. No? The surface area is circle. Then the area is okay. Now the force is a problem here. The pressure equal the first of all we need to get the perpendicular component of force. In force resolution lesson, I think you can remember. You remember we need to resolute this force into the perpendicular direction, because this is an angular force. No, because this angular force we can't find the uh, pressure. Okay, now the pressure we need to, sorry, force we need to resolute into the perpendicular direction. When it is resolute, it is 100 cos 40, sorry, 100, if it is resolute into angle direction, it is cos, opposite direction it is sine. Then I can say the 100 is a force into sine 30. 100 into sine 30 is the force, because opposite direction from the angle. Then the area is 22/7, 10 into 10 now, 10 into 10. Now you already know sine 30 means half. Sine 30 is half. Then what is the area? What is the area? From square centimeter, what is the area? Square centimeter? Twenty-two into 10 into 10, 2200. 2200 over 7. Yeah, 314.28 cm squared. But now it is square centimeter. We need to convert into a square meter. Same method. Then cancel it to 50. 50 divided by 314.28 over 100 into 100. 100 into 100. The answer is it possible to the question using cos-wise, like using cos 60? Yeah, very good, Tevan. If you want this angle is 60, no, because it is a perpendicular, then you can use cos 60. Cos 60 value also half, you already know. Cos 60 is half, sin 30 is half. Correct. Cos 60 you can use. Then the final answer is since there is a small difference in the answer when using 22/7 and 5 directly from the calculator. No, it's no problem. It's no problem. Only 0.00 value is changing. 0.00 value is changing. It's no problem. The answer is 1591, correct? 1000, yes. 1592.35 Pascal. You can use this every calculation by calculator. Now you have to try. Now you have to find a calculator. That's must. You have to find a calculator and practice now with this our paper discussions in future. In after this month we start a new special program for you with more additional class. paper discussion. Now, in this class, we mainly discuss past paper discussion class. You have additionally add to the for each week. Then you have 3 days for class only for SFT. In Monday class, we going with our exam paper discussions, our exams. In Tuesday class, we continue our lessons. I will arrange morning time. Probably it will Wednesday morning, not tomorrow. After 2 weeks, I will inform you have another past paper discussion special class up to exam. Okay, that's about pressure. Okay, our next one is hydraulic pressure. Hydraulic pressure. Now we discussed about, I think you remember, density, relative density, pressure. Our next topic is hydraulic pressure. Now we have another 4 topics. Hydraulic pressure. Hydraulic pressure. Hydraulic pressure. Yeah, atmospheric pressure is a little bit complex. That will stop with hydraulic pressure part. Then next week we can continue with, if you have the pressure you already know, hydraulic pressure if you already know, we can quickly discuss the atmospheric pressure, and we can go for Pascal's and Archimedes every theorems. Then static fluid is complete. Okay. Hydraulic pressure. Hydraulic pressure mean the pressure, normally pressure mean the pressure generated by an external force. The pressure mean some something agent generated by the external force on any surface, on any unit area. Now the hydraulic pressure mean the force generate on a unit area in a by any liquid, by any, actually hydraulic mean by in a liquid. Okay, when we consider about pressure of, when we consider about one point, when we consider about one point, think this point is A, one point on any, in a, think this is a liquid, this is any liquid, like water bath. If we consider any point, there are 3 main factors affect for hydraulic pressure on this A point. Then PA, the pressure of A point, affect 3 main factors. The first one is the height of the water, height of the liquid, the height of the liquid. Height of the liquid. Height of the liquid. That means the height mean this surface level to the height, the depth actually, okay, the depth. Not like, not this depth, okay, not this one, the height from the upper surface, the height from the upper surface. The second one that we called as simple H, that we called as simple H, that we called as simple H. Okay, the second factor is the gravitational acceleration. No, sorry. Yeah, gravitational acceleration also affecting, but that's the second factor is the density of the the density of the liquid. Normally, the density of liquid, the symbol is rho. The density of liquid density normally we use rho. This is a Greek letter rho, not like P. Okay. It like this. That's rho. That is rho. The density of the liquid. That's the second factor effect on hydraulic pressure. There is another factor, that is gravitational acceleration. Gravitational acceleration. Gravitational acceleration. Gravitational acceleration, it is G. It is G. Then according to these factors, the hydraulic pressure, the pressure of any point in a liquid, it is, we can find by H rho G equation. H rho G equation. H rho G in O level time also you already know. The pressure of any point in a liquid, that is, that we can measure, that we can calculate by pressure equal H rho G equation. The rho is the density of the liquid. Density of the liquid. Normally, if I consider the density of solid object like this, density of solid object, that is D. The symbol is D. The density of liquid, normally we use rho. In Bernoulli theorem, you can see the difference between D and rho. Solid object density, we consider D. Liquid density, we consider rho. We get as rho. Okay, note down. Note down like this. First point, hydraulic pressure. Hydraulic pressure, first point. The pressure exerted on the pressure exerted on any point. The pressure exerted on any point in a liquid called as the hydraulic pressure. Called as the hydraulic pressure. The pressure exerted on any point on a liquid called as the hydraulic pressure. Next point. There are three main factors. There are three main factors are affect on. There are three main factors are affect on hydraulic pressure. There are three main factors are affect on hydraulic pressure. First one. Okay, before that, draw this diagram. This diagram mark, this is the rho. That means density of the liquid. Then the height from the surface, that is h. Then we then write down three factors. After this diagram, write down three factors. Finally, write down the equation. Finally, write down equation. Okay, now 11. Okay, now I think that enough for today. Today we discussed the basic and we came to the mid of static fluids. Static fluid part we came to middle now. Now next week we can complete actually the static fluid we can complete next day. Next day also you have up to 11, then we can complete static fluid part. Then within one day we can discuss dynamic fluids. Then the this one is complete, and better to I want to tell you in the cell structure lesson it contain cell structure tute. You have without, yeah, few parts you have space. I will give you space written things as well. Then you need to read 2 to 3 times cell structure lesson, because it is a very large lesson, but very simple things. It contain compost production, uh, nitrogen cycle microorganisms, biogas production, yogurt production, wine production, toddy production, vinegar production. There are different simple things are there. I will discuss rapidly this lesson, very simple things. Therefore you need to 2 to 3 times when you receive within 2 to 3 days. When you receive, quickly come quickly try to read 2 to 3 times this cell structure lesson. If you can environmental chemistry also very simple, it also receive, that's also try to read, then we can quickly complete the lesson uh, in the few within few days. Okay, are you complete? If you complete, we can do the calculations in next day. Now very tired, I know you also very tired. Okay, if you complete, we can finish now for today. There is a problem. To yesterday we couldn't complete our MCQ paper. No? Only we 20 questions only we did. Okay, I will arrange a 3 hour time for you within this week. Then next month, before next Monday, I need to complete, because next Monday we need to start the structured part. Okay, I'll get let you know in the group. Okay, then good night.